Objectify Technologies is an additive manufacturing engineering service provider with expertise in metal and polymer additive manufacturing, with machinery and post-processing under one roof. Welcome to Objectify AddMics podcast, a conversational event for engineers, industrialists, and just anyone with a knack for additive manufacturing. For more info, visit us at objectify.co.in.
Dr. Godfrey is a senior fellow aerospace and defense strategy at SLM Solutions USA. Dr. Godfrey is a globally recognized authority on additive manufacturing. For Honeywell Corporation, he opened 3D printing lab in China, Czech Republic, India, Mexico, and 3D printing facilities in Phoenix, Arizona, with 2 being production facilities. He is also an author of the book Additive Manufacturing of Metals, the Technology, Materials, Design, and Production, Springer Series in Advanced Manufacturing. Dr. Godfrey is also the recipient of 30 plus patents in the US and similar numbers in the EU. Dr. Godfrey has spent the past 3 years in developing the additive global supply chain.
Thank you. What I'm trying to convey in this slide is that even though additive manufacturing is a phenomenal science, culture and the perception of risk is our greatest hurdle. For organizations not familiar with the science of additive manufacturing, you have to convince them that changing from an existing production that of a component that might today be sheet metal or castings or forgings to an additive technology is not risk. They see it as risk. So, for example, you have a difficulty getting a part, or you have to reduce the cost of something, and you want to use additive manufacturing. It is a typical response from an engineering organization to come back and say, hey, delivery issues, cost issues is a supply chain problem, not necessarily an engineering problem. When you want to reduce weight, that is an engineering goal, and they might be considering use of additive. But when there are large organizations, if you can pick any aerospace OEM, and they have within their organizations groups of people whose job it is to reduce risk. And so you have to convince them to change from a casting to a printed part. When you make that change, you're inducing risk. So how do you convince them to do that? Well, one way is through convincing engineers, chiefs, and even the customers, the FAA, ESA, that your additive manufacturing process is governed by specifications, powder specifications, ASME specifications, MMPDS. There's a lot of work that has to be done after you've developed the printing process. And the FAA has a pretty standard process or a belief that you have to prove that your additive manufactured part is as good as or better than what's in production today. They're not going to just let you go out and change a qualified part. If you're talking about a part that's on a new engine, a new design, and you 3D print it, okay, that's great. And they'll qualify the engine, and if it works, fantastic. But if you're talking about replacing a part that has been in production for 10 to 20 years and you want to now make it additive, you are, in essence, changing the manufacturing process, and by default, you are inducing risk. And you have to prove to them that the risk isn't there. And that's why I say culture and perception of risk is the greatest hurdle. We need to do the science to prove to the FAA and ESA that risk is not increased. To give you an example, there are aerospace companies that, one in particular, that over the past 2 years have had tragedies occur to their product line. I can guarantee you they have zero interest in doing something that might increase risk to their product. And we at in the United States, to get something approved, you have to go through a complete material characterization of the alloy through additive. That's what I'm trying to say here, is that you have to prove to people that additive is not a risk.
Thank you, Dr. Godfrey, for your very illuminating talk and perspective on having additive into a conventional process and reducing the perception that AM technology is not a risk, but a tool for making better products. You being a veteran in civil aviation AM components, we would like to understand what are the potential percentage of parts that you estimate will be converted to AM from the civil aviation sector.
To answer that with some degree of accuracy, I think we have to look at the civil aviation sector as a piece of pie. You have newer planes, planes that are 20 years old or less. You have planes that are 20 to 50 years of age. Right? I just put a part in production that was designed in 1959. And then you have the emerging market. So let's do the easy one, the emerging market. I think there's going to be an explosion in UAVs and drones, led by companies like Uber, Amazon, FedEx, DHL, and they're small, right? Every one of those things are they're not a jet. They're designed to carry a box or up to 4 people. I think all of those components, all of them, can be 3D printed because of their size. Now, that's not going to happen in 2021, but by 2050, I think we can say with some level of confidence that a vast majority of those parts can be printed, because the turbine engines are going to be small. They will fit in a machine. There's not going to be one big one. There's going to be 4 or 8 small ones. If they're electric, then obviously you're not going to print them. Well, you could print maybe some elements of the motor. So I was working a lot with Bangalore, India, on some power generation rotating components. So they could print some generators. We still have to get over that hurdle of rotating parts and understanding creep properties. So We could talk about that all day. So let me go into the next section, which is the aviation components that are in production today. I think from a interior of the aircraft, obviously lots of parts can be printed. If you went to Boeing Seattle plant right now, they have polymer machines sitting on the production floor printing parts. I was over at the Boeing Defense Helicopter plant in Mesa, Arizona, and they've got SLS machines printing plastic components right there. So it's happening today in aviation, in commercial aviation, for helicopters and aircraft interior. But again, those are the planes that are most concerned by the OEMs with risk. So we are printing some engine components, but that number is less than 1%. So if you look at it from a positive perspective, the industry is going to explode as OEMs, airframers and engine OEMs gain more confidence. So it'll never be 50%, but it could be 5 to 10 on the outside. If you look at really old aircraft, right? The answer there is very high, because you don't look at unit cost. Like, I mean, we are engineers, and we like to think that if a casting is $20, I got to print something for $20 or I can't compete. And what I try to tell people is, don't always look at unit cost. Look at working capital. So for example, and here's a perfect example, is I'm at Tinker Air Force Base, which is a repair overhaul facility. And a gentleman says to me, I've got $3 billion worth of aircraft I can't fly because each one of them has a part I can't get. All right. So if you have a part where the casting is normally $500 and you print it for $1,000, is that a good investment? Because with that $1,000 part, I can now get that $20 million aircraft in the air. What are you willing to pay to get that jet in the air? Another example is if we had this problem all the time. If you need 60 castings a month and your casting house shorts you 10, and they do that repeatedly, but that casting, I think it was like $250. But when you don't ship, if you don't have that part, you don't ship that engine. If you don't ship that engine, then your customer fines you $10,000 a day or $20,000 a day. Now all of a sudden, that $250 part costs you $250 plus $200,000 because you were late shipping the engine. Because if you can't ship the engine, they're not shipping the plane. And so you need to look at working capital. The cost of that casting is not $250. It is $250 plus the lost revenue of not shipping the engine, plus the fines your customer is going to give you every day that you're late. That's the cost. That is what we call working capital. So if you look at older engines and older aircraft, I think the number can be 40%. It can be way up there, but you have to give them confidence that it's as good as what they expect.
Thank you so much, Dr. Godfrey.